Abu Rayhan Muhammad ibn Ahmad al-Beruni was a remarkable scholar. He was born around 973 CE in Khwarazm, now part of Uzbekistan. Al-Beruni lived during the Islamic Golden Age, a period of great advancements in science, culture, and learning. Despite political instability in his homeland, he pursued knowledge with exceptional intellect and curiosity. His contributions influenced scientific thought for centuries. Al-Beruni was a true polymath, excelling in many fields. He made significant observations and calculations in astronomy. He developed new methods in mathematics and applied them to various problems. His expertise extended to physics, geology, and cartography. He also studied history, chronology, pharmacology, and mineralogy. His intellectual reach included Indology, the study of Indian culture, and philosophy. The Islamic Golden Age provided fertile ground for scholars like Al-Beruni. From the 8th to the 14th centuries, Islamic civilization experienced a surge in intellectual activity. Rulers and wealthy patrons supported scientific inquiry and the translation of ancient texts. Libraries and observatories flourished, becoming centers of learning and research. Scholars from diverse backgrounds collaborated and exchanged ideas. This environment encouraged critical thinking and innovation. Al-Beruni benefited greatly from this atmosphere, accessing a wealth of knowledge and engaging with other leading minds of his era. A significant part of Al-Beruni's life involved extensive travel. Around 1017 CE, he journeyed to the Indian subcontinent. He spent many years there, particularly in regions now part of Pakistan and northwest India. This journey was partly due to the patronage of Mahmud of Ghazni. In India, Al-Beruni immersed himself in learning the local languages, including Sanskrit, and interacted with Indian scholars. Al-Beruni was a pioneer in his approach to science. He advocated for a methodology based on direct observation and empirical evidence. He believed true understanding came from carefully watching and recording natural phenomena. This was a departure from relying solely on ancient texts or established dogma. He encouraged scholars to see for themselves and gather data meticulously. His commitment to observation laid an important foundation for the modern scientific method. Beyond observation, Al-Beruni stressed the importance of meticulous measurement and experimentation. He understood that quantitative data was essential for scientific accuracy. He designed and used various instruments to make precise measurements in fields like astronomy and physics. He developed new techniques for determining specific gravities. He sought to test prevailing theories through experiments. This practical approach was revolutionary for his time. Critical analysis and objectivity were central to Al-Beruni's scientific endeavors. He rigorously questioned and cross-referenced data from different sources and cultures. This allowed him to identify inconsistencies and errors in existing knowledge. When studying other cultures, such as India, he aimed to present their knowledge and customs accurately, without personal bias. Al-Beruni's monumental work, An Inquiry into India, stands as a prime example of his rigorous methodology. Commonly known as Al-Beruni's India, this book was completed around 1030 CE. It was the result of over a decade spent in the Indian subcontinent. He learned Sanskrit to access primary Indian sources and engaged in discussions with local scholars. The book covers a vast range of topics, from Indian sciences to social customs. It reflects his thorough and systematic approach to research, making it an invaluable historical document. The creation of was a monumental undertaking for Al-Beruni. He spent approximately 13 years in various parts of the Indian subcontinent. This extended stay allowed him to gain a deep understanding of Indian civilization. He learned Sanskrit, enabling him to study original texts. He actively sought out Indian scholars and engaged them in dialogues. This immersive approach was fundamental to the book's authenticity and depth. Within, Al-Beruni documented Indian achievements in astronomy, mathematics, and metrology. He discussed their theories of cosmology, concepts of time, and understanding of the Earth's shape. He explored their sophisticated number systems, arithmetic, algebra, and geometry. His writings show a profound respect for Indian intellectual traditions. He presented their scientific knowledge systematically, often comparing it with Greek and Islamic theories. This comparative approach highlighted the unique contributions of Indian scholars to global scientific understanding. Al-Beruni's exploration was not limited to the sciences. He offered a comprehensive view of Indian culture and society in the 11th century. He described various Indian philosophies, Hindu religious beliefs, festivals, rituals, and the caste system. He also touched upon Indian languages, literature, and geographical knowledge. His aim was to provide a complete picture of India to his readers. Holds immense significance for both medieval science and the study of India. It served as an unprecedented cultural bridge, providing the Islamic world and later Europe with a detailed account of Indian civilization. By documenting Indian knowledge, Al-Beruni played a crucial role in its preservation and transmission. His work facilitated the flow of Indian mathematical and astronomical ideas into the Arab world. Remains a vital primary source for historians, forming a cornerstone for the field of Indology. Section 4. Measuring the Universe, Al-Beruni's contributions to astronomy, mathematics, and earth sciences. Al-Beruni made remarkable contributions to astronomy. One of his most celebrated achievements was the accurate calculation of the Earth's circumference. He achieved this using a novel trigonometric method. This method involved measuring the dip of the horizon from the top of a mountain of known height. He conducted this experiment at Nandana Fort in present-day Pakistan. His calculated value for the Earth's circumference was approximately 39,987 kilometers, close to the modern accepted value. His astronomical knowledge was compiled in the Masudi Canon. This encyclopedia of astronomy and geography rivaled Ptolemy's in scope and detail. It contained extensive tables for planetary motion, predictions of eclipses, and positions of stars. Al-Beruni also engaged with complex astronomical questions, discussing Earth's rotation and the heliocentric model. He designed and improved astronomical instruments such as the sextant and astrolabe. In mathematics, Al-Beruni significantly advanced trigonometry. He developed new formulas and provided precise tables for sine and tangent functions. His work in geodesy was foundational, developing techniques for measuring distances and determining latitudes and longitudes. This was crucial for accurate mapmaking and understanding global geography. Al-Beruni also worked on algebraic equations and explored concepts related to series. Al-Beruni's scientific inquiries extended into physics and geosciences. He determined the specific gravities of at least 18 precious stones and metals with remarkable accuracy. In geology, he theorized that the Indus Valley was an ancient seabed filled with alluvial deposits. He investigated hydrostatics, studying artesian wells and springs. He compiled a comprehensive encyclopedia of medicines in his Book of Pharmacology. His recorded values are very close to modern scientific measurements, a testament to his experimental rigor. His understanding of slow geological processes was ahead of his time. Section 5. Enduring Echoes. Al-Beruni's influence on medieval science and beyond. Within the Islamic world, Al-Beruni's works quickly gained immense respect and authority. His books became standard references in madrasas and among scholars. His rigorous scientific methodology influenced subsequent generations of scientists in Islamic lands. Thinkers who followed him built upon his findings in astronomy, mathematics, and other fields. His comprehensive approach to knowledge and dedication to accuracy set a high standard for scholarly pursuits. The transmission of Al-Beruni's knowledge to Europe occurred through various channels. Key ideas, especially his astronomical data and mathematical techniques, gradually filtered into European scholarship. This often happened indirectly through translations of other Arabic texts that cited his findings. His astronomical tables and methods for determining specific gravities found their way into European scientific discourse. Al-Beruni's contributions played a significant role in shaping medieval science. He provided more accurate astronomical data, crucial for calendar making, navigation, and further research. His improved mathematical techniques were essential tools for scientists. His empirical approach and emphasis on experimentation were vital steps toward the modern scientific method. His work on specific gravities laid foundational principles for mineralogy and physics. His geographical insights contributed to a more accurate understanding of the world's layout. The legacy of Al-Beruni continues to resonate powerfully even in the 21st century. He is celebrated as a pioneer of the scientific method, championing empirical observation and critical inquiry. His work serves as a model for objective and respectful intercultural scholarship. His name is honored by the Al-Beruni crater on the Moon, a fitting tribute to his enduring impact on our quest for knowledge.